Today we're going to talk about Workbook 6A, Exercise 3. In the textbook, that'll be on page 12 and 13, continuing on with the idea of algebra and some variables so that we don't always know the number we're working with. On page 12, problem number 18, you see that John has 4 bags of red beads and 3 bags of green beads, and there are X beads in each bag. A little bit of a tongue twister there. So the first thing we want to know and start solving for is find the total number of beads in terms of X. How many beads are there? Well, I made red bags because I can't draw the red beads, but there are X in each. So notice, we could even just color code it. I have the X beads out of the first bag and the second bag and the third bag and the fourth bag. But even though the other beads are green, there are still X of them. So I have all of those beads, and you could say that I have 4X beads that are red, and I have 3X beads that are green, but the truth is, when you go right down to it, what I have are 7X beads, right? Whatever there are 7 groups of X. And the fact that they're different colors doesn't change anything. Okay? Then the next question asks us, let's do this, 7X beads total. The next one asks us how many more red than green. Well, how many red are there? There are 4X red. We know that already. And how many green are there? Of course, there are 3X. Now, remember, we've talked about this since very, very early in primary math. If you say how many more are there, that's a subtraction problem. Just because we're doing algebra doesn't change that, right? If I said that there are 10 boys and 4 girls, and I said how many more boys than girls, you would say there are 6 more boys than girls. We've done that for a long time. Just because it has a variable in it, the rules don't change. It's the same thing it's always been. And even the subtraction is the same too, right? If you have 4 X's and you get rid of 3 X's, guess what you have? You have 1 X, or a simpler way of writing that is just X more red beads. Could you find that from the picture? Sure. These beads are the same. These beads are the same. These beads are the same. I have exactly 1 more bag of red beads, and in that bag are X beads. It all makes sense. Please don't make it hard. I know it looks different to your eyes, but don't let it make you confused. It's very simple. It's the same thing we've been doing. Just think about it a little bit. And of course, if it helps, you can always make up a number, and we'll pretend in purple. Let's just pretend that there are 6 beads in each. So then you would see that there are 24 red, and there are 18 green. And if you added those together, you would see that there are 42 total. And guess what? 7 times 6 is 42. And you said how many more red than green? There are 6 more. And of course, 4X minus 3X would be 24 minus 18, and that's 6, which is equal to X, right? If you put a number in it, it makes it more concrete because we can actually think about numbers. But then you go back to the variable, the X part of it, and begin to understand how to think about numbers when all you have is a variable. The rules don't change, you just have to think about it really hard. All right, so number 19 wants us just to simplify. Now they drew pictures for you, and that's a great plan. If it helps you to have the pictures, draw them or look at the textbook, or in your workbook, draw your own pictures. You know what else you can do? 5R just means I have R and R and R and R and R. That is 5R. You could also think of it, of course, as not 5, but as r plus r plus r plus r. 5r, but if you have 5 r's and you take away 2 of them, that one goes away, that one goes away, what do we have? We have 3r. 5r, r plus r plus r plus r plus r, minus 2r, minus r minus r minus r is 0, r minus r is 0, and what I have left is 3r. So that's two different ways to look at it, plus of course the book draws bags that represent r marbles in each one. So look what we have. Again, 5r minus 2r plus 3r. Again, we have things that come together to make 0. R minus R is 0. It doesn't matter if it's 5 minus 5 or 5,000 minus 5,000. And I can put this R and negative R minus R together as well. So those both equal 0. What do I have left? I have 1, 2, 3, 4, 5, 6 R left. Could you do it without drawing it? Actually, you can. Think of, well, 5r minus 2r plus 3r. You could just think, well, if you have 5 and you take 2 away, you have 3 r's. That's what we have. And we're going to add 3r. Well, 3r add 3r means you have 6r. I love math. I love the fact that you can think about it in so many different ways. 5r and 3r, I can add them together to get 8r. And then when I subtract 2r, guess what I have? 6r. Isn't that nice? There are so many ways to think about this. They're all very logical. So you can't really count on your fingers when you do algebra, but you can do everything with a lot of logic and thinking. Look at the next one. It's a little different. What's different about it? 5r minus 2r, but this time it's just plus 3. Remember when we had 3 random marbles outside of the bag? Okay, and so 5r minus 2r, I can put those together. That's 3r. But when I have 3r plus 3, I have 3 r's and I have 3 more individual things, but I can't combine those anymore. Again, there's a picture in the book to help you think about that. You're just adding 3 extras. Not 3 r's, just 3 extras. So sometimes you can't just write it down with a single answer. This 19A was 3r, 19B was 6r, but 19C, you have to call it 3r plus 3. You can't make it any shorter than that. What about letter D? Look what they've done. This is a 3, like 3 marbles standing by itself, but here's 5r minus 2r plus 3r. What do you get when you combine your r's? Because what really happens is the r's will come together, but that 3, it just hangs around out there. There's just 3 extras sitting out there. But I have r plus r plus r plus r plus r. Take away 2 of them, it says, that's minus 2. Add 3 of them. And by the way, there's 3 extras out there. So all together, you can see I did the order they had. I drew 5, I took 2 away, I put 3 more down. That gives me 6r plus 3. I don't have 9r, right? The 3 is just kind of by itself. I have 6r plus 3. Number 20, every time they do a little bit of something different. What do they do differently on this one? Well, I have 4k and 3k, and I have 5 and minus 2. So let's talk about this. We have k and k and k and k and 5 and k and k and k minus 2. When I combine things, these k's will all come together and give me 7k. And we, of course, know that 5 take away 2 is 3. So the answer to that is 7k plus 3. Now, it may not feel like an answer. It's more like a simplification. I've made it as simple as possible. I can't make it any more simple unless you told me what k is. Now, if you say k is 100, all right, well, I can go further. But unless I know what k is, I can't do anything else with that. All right, then, very kindly, they gave us a whole bunch to practice. And so I'd encourage you to pause the recording, do these real quick, write them down, and let's see if I get the same answer that I'm getting. 5a plus 4a can come together. All together I have 9a. I have 5 of them, and then I have 4 more. So altogether I have 9. Letter B says 8c subtract 5c. I had 8, but 5 went away, so now I have 3, and what I have are c's. 7k minus 2k plus k. Again, it's lovely. You can do it either one of two ways. You can do 7k minus 2k is 5k and add k for 6k. Or you could do, combine your positive values. Altogether I have 8k's, but I'm going to take away 2 of them and I get 6k. Either way, you get the same answer, of course, which is lovely. You might notice that on each line they do something a little bit different. The first line we're just combining variables. On the next line we have some variables and some numbers. So remember that the 3x minus x will go together, but the 6 just sort of tags along. It has nothing it can be combined with, but it does not combine with the x's because it does not belong in the x group. If you have 3 x's and you take 1 away, and by the way, if it doesn't say so otherwise, it does mean 1x. We generally don't write a 1. It's called understood. It's an assumed 1. I've already done that a few times and not said it out loud, but just so you know, the x is 1x if not stated otherwise, but we understand that, right? It makes sense. 3x, take away x. Of course, that's not 3 because we have x, x, x. That's what we mean by 3x. So when we take away x, what we have are 2x. Add 6. 7m plus 7 minus 2m will leave us with 5m plus 7. 5s plus 10 plus 2s gives us 7s plus 10. On the next line, they make it a little more complicated because now we have 2y and a 5, 3y and a minus 2. So we have to combine both the variables together and the numbers together. So if I have 2y and I add 3 more y, altogether I have 5y. And if I have 5 and I take away 2, I have 3 left. On the next one, I have a 9 plus 4m minus 3m minus 8. It doesn't matter, by the way, which one you put first. We generally put the variable in front and the number second. It's not a big deal. But 4m minus 3m is 1m. And if you want to write the 1, that's okay. You don't have to write the 1. 9 minus 8 is 1. So we could write 1 plus m, 1 plus 1m, 1m plus 1, or m plus 1. Each of these means exactly the same thing as the others, and however it's written, you need to not be confused about the different things, right? I always say it's kind of like when one person walks up to me and says, Mrs. Barnett, I'm so excited I made an A on my test, and another person walks up and says, hey Mom, guess what? I made an A on my test too. Nobody falls on the floor confused because somebody just called me Mrs. Barnett and somebody just called me Mom. I have multiple ways you can speak about me. One person in the world calls me wife. 2 people in the world call me daughter, right? And so they don't actually call me daughter, but the idea is there are more than one way you can refer to a person, and there's more than one way you can refer to an expression like this. All of them are the same. Let's not be confused by that. 8r minus 2r is 6r. Plus 6 minus 6 is 0. You could call it 6r. You could call it 6r plus 0. Either one. Generally speaking, I would say that 6r is kind of the preferred way to write it, and I would say, back to the other one, m plus 1 is probably the way that would be most often written for this problem. On the third line, it's just a little bit of a hodgepodge. We have 8p minus 3p minus another p. How many p's do we have left? We started with 8 of them, and we took away 3 and we took away another one. That leaves us with 4 of them. And that plus 2, it just comes on down. It doesn't combine with anything. But on the next one, I have 8 and then plus 8w, and then plus 5 and minus 2w. So altogether, I have 13 and I have 6w. Or if you prefer, 6w plus 13. Either way is fine. On the last one, letter L, I have 7 and another one is 8h. I'm going to subtract 4h and another h, so altogether I'm going to subtract 5h, which gives me 3h. You could do that any order you want to. You could say that h minus h is 0. So those are just totally gone. And then you have 7h minus 4h is 3h. That's a great way to do the problem. You could do it one step at a time. 7 plus h is 8h, minus 4 is 4h, minus 1 is 3h. Right? So don't get stuck in the one way to do a problem. Just realize there's lots of different options and go from there. All right, you are ready to do exercise 3. This is the last one about algebra, so hit it hard and do it well.